Okay, I'm back with another quick lesson about Gibbs Free Energy. Gibbs Free Energy is basically the available energy that you have in a reaction. So the formula for Gibbs Free Energy is delta G equals delta H minus the temperature in Kelvin times delta S. Now, you might recall that delta H is enthalpy, and it refers to the heat and energy within a reaction. Delta S is entropy, and that refers to the random motion of particles within an equation. Okay, keeping this in mind, we are going to find the Gibbs free energy of a few different types of equations. Let's begin with energy plus H2O liquid results in 2H2 gas plus O2 gas. Okay, keeping in mind that delta G equals delta H minus temperature times delta S, we're going to try and figure out if this equation is spontaneous or not. Now, what spontaneous means when dealing with this particular equation is that the delta G, the Gibbs free energy, is negative. Now, in order for it to be negative, there is one possibility that will always result in a negative Gibbs free energy, and that is if you have a negative delta H minus a positive delta S. And then if you have a positive Gibbs free energy, the only combination for always having positive Gibbs free energy is a positive minus a negative. Now, if either of these two symbols are the same, it's undetermined until we have more information, which we will not be getting to today. Okay, so back to this equation at hand. Now, in order to find the delta H, we need to determine a bit information about the energy. More precisely, when looking at the reactant side of the equation, the energy is visible. When you look at the product side of the equation, it's gone. That means that the products have absorbed the energy. They've taken in the energy that went into the reaction as a reactant. That means that the overall graph of this equation is going to be endothermic, which means delta H is positive. Delta S refers to the spontaneous motion of particles. Now, if you look at the reactant side of the equation and you count the number of moles, there's really only one mole here. So you've got one. On the other hand, on the product side, there's 2 moles of this, 1 mole of this. That's 3. So the spontaneity of this equation these compounds has dramatically increased, which means that delta S is also positive. Now, delta G equals a positive minus temperature times a positive. Well, we don't know exactly what the numbers for delta H and delta S are. So that means that this particular equation, is undetermined until we have more information. Simple enough. Let's try another one. Energy plus 2NH3 plus CO2, and these are both gases, becomes NH2 CONH2 aqueous plus H2O liquid. Now again, to identify the delta H, we have to look at the energy. This is the same problem that we had in the beginning, as in the energy is visible in the reactants but not in the products, which means the products have absorbed it. So delta H is positive. Delta S, the randomness, is a little bit different now. We have 2 moles of NH3, 1 mole of CO2, it means we have 3. On the bottom here we have 1 mole of NH2CONH2 and 1 mole of H2O, which is 2. Well, in this one, the delta S is negative. So looking at delta G equals a positive minus T times a negative, well, that's the same as a positive plus a positive, because 2 negatives make a positive. So delta G is always going to be positive in this scenario, which means it's never going to be spontaneous. Let's try one more. C2H3OH liquid plus 3O2 gas becomes 2CO2 gas plus 3H2O gas plus energy. Well, in this one, the energy is now revealed itself in the product, which means that the energy that was in the reactant side, in the C2H3OH and the 3O2, is now being released. So that's a negative delta H. Delta S, well, let's see. We've got 1 mole of C2H3OH and 3 moles of O2, which is 4. And we've got 2 moles of CO2 and 3 moles of H2O, which is 5. Well, delta S is still increasing. So delta G equals a negative minus T times a positive. Well, a negative minus a positive is always going to be negative. So this particular reaction is always going to be spontaneous because the Gibbs free energy is negative. Well, that's a brief introduction to Gibbs free energy. I hope that helps.